Hi, I'm John Davis, CTO of ENTEXS Corporation. Here at ENTEXS, we engineer and manufacture technologies specific to hemp and cannabis processing. I'm excited to share our new product, which is our Mini 1 extraction system. This is an end-to-end solution for a biomass input to a refined distillate output. So in this video, I'll be walking you through the Mini 1 extraction system. This system starts with the extraction part of the process. We utilize ultra-cold ethanol for the solvent to remove the oils from the biomass. And that's what this enclosure is all about. So what we do here is we chill ethanol, which is in the process tank behind me, down to -60 degrees. That runs through the biomass in the extraction centrifuge, which is over here, using all automated and control routines that can be operated from the HMI tablet. This is an explosion-proof tablet that can be brought into the extraction area in the solvent zone. This enables full autonomous control of your batch processing in the extraction part of the process. So with the extraction part of the process, using ENTEXS technology, the only manual part of this is putting a bag of biomass into the batch centrifuge, pressing cycle start, and coming and pulling that spent bag of biomass out. Cycle time is about 20 minutes on that. In the background, what's happening is fully automated routines are running, which measure real-time solvent level, temperatures, pump pressures, centrifuge, vibration levels, speeds. So there's a whole bunch of stuff that's going on in the background that enables seamless and easy and efficient user interface. So to start the process, you put a bag of biomass into the batch centrifuge. This is as simple as opening up the lid, placing your bag of biomass in, and pressing cycle start on the control. This also enables you to put the biomass weight, batch record, any information of batch ID that you're running, which captures a data record for that piece of biomass going into the equipment. This is important for GMP, EU GMP processes for data records and quality. After selecting cycle start on the HMI, the process self-fills up to the level sensor that's integrated into the batch centrifuge. This process then does a extraction loop, which continuously flows cold solvent through the biomass using agitation and pump closed loop flow. That routine usually takes about 15 minutes. And during that time, that's when the bulk extraction of your oil is coming for your biomass that's in the centrifuge. After that's complete, the centrifuge drains into the batch tank, and you do a clean solvent rinse to recover any residual biomass oils that are trained in the product. That is another about 3 or 4 minutes quick rinse cycle to capture maximum efficiency of your product. After the rinse cycle is complete, the system drains, does an automated drain cycle. We have low level sensors in the support module over here that pulls all of the liquid out of the centrifuge, and then we need to do a dry op. So this is, of course, a centrifuge. It spins up and centrifuges out residual solvent that's trained in the biomass. With the Mini 1 system, due to the size, we can run a direct drive system. It features mechanical seals to eliminate any leakage you have out of the bottom, which is common in these types of pieces of equipment. This system also runs up to over 2,000 RPM in speed. So it does a really high G-force centrifuge, especially regarding the size of it. We also have vibration monitoring on it to have the system shut down in case there's excessive eccentric loading of the biomass inside the vessel. After that drying op is complete, the HMI will inform the user that the cycle is complete and you can take your bag of biomass out. We also have safety mechanisms in place, lid switches and whatnot, so you can't open the centrifuge when it's running or else it'll shut the equipment down, like a standard washing machine. So when that cycle is complete, or when it's running, you can see product quality visually with sight glasses we have integrated into the equipment. So on top of the centrifuge itself, in the process lines, and all around, which you can't see in this video. But they're integrated into roughing filters, which we have in the back to capture any big particles if your bag comes apart or whatnot, and you have stems or sticks or whatnot. It captures all of that. You can see it in the back of the equipment. And also integrated into the filtration, which I'm going to talk about next. After the extraction cycle is complete, what runs in the background now is a filtration of your product, your micella that comes out of your extraction, going to solvent recovery. What this is our filtration system for the Mini 1. It uses a bag filter, sub-micron bag filter with a color remediation carbon set prior to evaporation. We really don't need much particulate filtration because our product process is so clean. We have roughing filters on the extraction side, and we really don't see a need for much particulate filtration. We also noticed over time in multiple systems that we've installed that this is a high maintenance area where you're coming and interfacing with this, and when you're changing filters and when you're interfacing with the filter set, you're typically spilling some product, and that's why we incorporate drip trays in all of our filtration solutions. This makes it very easy to service the filters and clean up any spillage that you might encounter. The filter pump also has integrated pressure sensors, so you can monitor what the filter pressure is, and you can also get visual feedback with the levels with the flow sight glasses as well. So the final part on the solvent side of the system is removing the solvent from your oil, and that's what we have here. This is our solvent evaporator using a preheater rising film evaporator, so you start increasing solvent quality as you come up this heater, and you do your bulk evaporation on the falling film evaporator. This is a good piece of equipment to use for bulk solvent removal, but you're still going to have residual solvent on their concentrate which comes out of the bottom of this piece of equipment. So you can operate this using our remote touchpad tablet, using the evaporation routines. This thing runs down in the 100 torr range of solvent vacuum. And this piece of equipment is designed, of course, for the Mini 1 system, which runs around 0.3 or 0.4 GPM of flow rate. So in conclusion, this is the solvent part of the extraction process. This typically goes in a Class 1 Div 2 zone because we're running ethanol as a solvent. It's all closed loop, so you don't have much solvent vapors in the work area. But this is the solvent zone, so it can be separated from the distillation equipment, which I'll talk about next, or it can be mated together with proper ventilation and airflow. One thing I want to mention on this is all closed loop. So once your biomass goes into the extractor, your oil does not see oxygen, it does not get oxygenated, and also your solvent gets recovered. So this is a closed loop process. Your only solvent loss is solvent entrained in the biomass that's centrifuged out, and that goes out with biomass waste. You lose just a very small amount of ethanol during this process. The rest is recovered. The condensate is sent back to extraction and reused in the extraction process. It's all automated, it's all touch screen, and like I mentioned at the start, the only thing you have to do is put your bag of biomass in, press cycle start, and you can go about and do other things in the lab. This concludes the extraction part of the Mini 1 system. Now I'm going to talk about the ENTEXS refining or distillation solution. What we've developed is a dual pass distillation continuous flow system that has a vacuum jacketed feed tank that can desolve and decarb your product if you send it over directly from evap. So there's no oxygenation of the product, like I said, from even the biomass going into the system to this part of the process. There's no transfer from rotovaps, there's no open containers, it's all closed loop, gets filled into this feed tank and decarb. This is a vacuum jacketed mixer. We run a heating loop on the jacket. We have a cold trap to condense any solvents and light volatiles out of the product before it goes through the distillation part of the product. You can also do real-time sampling, so even under vacuum, so you can take product quality samples, run on an HPLC, or run visual quality samples in your process. So the whole thing is operated from this touch panel here, which you can control temperatures, vacuum levels, mixing speeds, pump speeds for a single point of operation, and it includes batch records, graphs, and everything you might need for your quality system. So once your product is ready to be run through the refining part of the process, you run through the dual pass distillation system. This is one of the most frustrating parts of the extraction process in general, is running distillation, and the fact that a lot of systems don't have heated and jacketed lines where you get product quality, which is very viscous at this point, stuck in the lines, so you have to use heat tape or heat guns, multiple heat guns for most systems if you're familiar with those. So we've taken great care to heat and jacket everything from the feed tank on through the system, as I'll demonstrate. We also have a dual pass system, so you don't have to run multiple passes through the same white film evaporator, changing temperature and vacuum settings. So what that enables you to do is run a single continuous path flow from your feed tank all the way through to a refined final product. So it starts with the first pass feed pump. Once that's enabled, you pump your product up to the first stage WFE. This strips light volatiles out of your product and preps the product for final pass distillation or your final product output. This is captured with our cold trap here in those terms of those light volatiles, and also can be captured with the intercondenser of this first stage WFE. And that product is collected in these vessels. Your main product is collected off the jacket of the WFE, maintained in the site level here, and fed from the outtake pump of your first stage to the final stage WFE, which is this piece of equipment here. Now this stage runs at a lot hotter jacket temp, a different intercondenser temp, and again, the product at this point is very viscous because your residue is almost a hardened compound at that point, while your distillate is a very, at room temperature, dense product. So we keep everything jacketed, even the offtake coming off of the WFE, just so you get good product flow. You never get buildup of product in those areas. Everything gets pumped out so you don't have vessels filling up over time. And you go with your waste, your residue off of this pump, and your final product, which comes off of this pump. So this is your good product you're going to take and use in your application. This has a dual cold trap system to protect the vacuum system pumps and also maintain vacuum level. One vacuum cold trap running off of the ULT chiller and one off of the liquid nitrogen system. So this is a very cold trap that can reach levels down in the 10 millitorr range even, which is very low vacuum for this type of system. We run variable speed drives on the mixers so you can control mixing rates. VFDs on all of the pumps, you can control all the flow rates and all of the flow conditions of the pump. We have multiple thermal control units that are TCUs in the back of the system that are industrial type TCUs, not the little lab TCUs that are on most of the systems out there. So this is really an industrial grade processing and refining system meant for this industry, not the typical lab scale system that uses heat guns and heat tape and little lab circulators. So this is something that has taken many iterations to really perfect, and it works fantastic for customers looking for a solid continuous refining solution. So one of the advantages of this equipment with the final product coming off of this distillate pump is that product has not been oxygenated from the biomass input part of the process. So there's no open areas in the process from biomass in to your final product out. And what that results in is a really high quality, vibrant color product that you can't achieve if you're oxygenating that product and doing open pours and transferring from container to container or feeding from open containers. We've tested that. It's a really night and day difference in the product quality coming out using this closed loop, truly closed loop process. So in closing, we really look forward to hearing from you, working with you as a customer, and we also can support installation of our equipment in your facility. So that if that includes the upfront end design, really designing your facility around our equipment and around the workflow of the extraction part of the business, we can support that. If it's putting this equipment into an extraction booth that's already designed in, we can really mate and design the equipment to be configured to that specific orientation. So we can really custom engineer our solutions as well, depending on what your need is as a customer. Look forward to hearing from you.